Have you ever pondered about what happens when a star collapses under its own gravity? It births a phenomenon that has intrigued astronomers and physicists for centuries: a black hole. These cosmic enigmas, despite being understood at a basic level, still hold a plethora of mysteries. From the paradox of information that questions fundamental principles of quantum mechanics, to the inexplicable nature of event horizons, black holes continue to baffle us. Today, we unravel the enigma that is a black hole. The birth of a black hole is a spectacle of cosmic proportions. Let's delve into the depths of the cosmos and understand this fascinating phenomenon. You see, black holes don't just appear out of nowhere. They are the result of a life cycle of a star, specifically a massive star. But how massive, you ask? Well, we're talking at least 3 times the mass of our own sun. Now that's a giant! These gargantuan stars burn bright and hot, fusing elements in their cores. However, the fuel isn't infinite. Eventually it runs out. When this happens, the star can no longer resist the crushing force of its own gravity. It begins to collapse inward, a process known as gravitational collapse. The collapse triggers a dramatic explosion, a supernova, which is one of the most energetic events in the universe. It's like a fireworks display on a cosmic scale, outshining whole galaxies for brief periods of time. But here's where things get really interesting. The core of the star, now stripped of its outer layers, continues to collapse. Under such extreme conditions, the laws of physics as we know them start to twist and warp. The core shrinks to a point of infinite density, a singularity, surrounded by a region where gravity becomes so incredibly strong that it warps the very fabric of space and time. This is the event horizon, the point of no return. Anything that crosses this boundary is swallowed, never to return. In the aftermath of the supernova, the remnants of the core that haven't been blown away collapse to form an incredibly dense point. This is the birth of a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. In the aftermath of a supernova, a black hole is born, a region of space where gravity is so strong that nothing, not even light, can escape. Black holes, though invisible, exhibit certain unique characteristics. They're like the invisible superheroes of our cosmos, wielding powers so immense they can bend the very fabric of reality. The first of these characteristics is their incredible gravity. Imagine a star 10 times more massive than our sun, compressed into a space no larger than a small city. That's the kind of density we're talking about here. Such immense gravity can bend light and time itself, creating what we know as the event horizon. This is the point of no return. Once you cross it, not even light can escape the black hole's gravitational pull. Then, at the very heart of a black hole, we find a point called the singularity. Here, matter is crushed to infinite density, the laws of physics as we know them cease to apply, and space-time curves infinitely. Despite being invisible, black holes are not entirely undetectable. They reveal themselves through their influence on nearby matter. For instance, they can cause nearby stars to move in unusual ways or make light from a distant star bend around them, similar to how a lens bends light. So you see, black holes, though unseen, are far from unfelt. Their gravitational pull, event horizons, and singularities not only shape their immediate surroundings, but also leave an indelible mark on our understanding of the universe. Despite their invisibility, black holes influence the cosmos in ways we are just beginning to understand. Black holes, once just a theory, are now a fascinating reality of our universe. Born from the violent explosions of supernovas, they are objects of extreme density, with gravitational pulls so strong, not even light can escape their grip. These cosmic phenomena are not only intriguing in their own right, but they also play a significant role in the grand scheme of our cosmos. Imagine the universe as a grand cosmic ballet, with galaxies, stars, and planets all dancing to the music of gravity. In this grand performance, black holes are the prima ballerinas, their immense gravity choreographing the movements of stars and galaxies around them. Yet, despite their pivotal role in the cosmic ballet, black holes are shrouded in mystery. Questions about event horizons, the paradox of information, and the true nature of these cosmic enigmas still puzzle the brightest minds in astronomy. While we've shed some light on black holes today, they remain some of the most intriguing and mysterious entities in our universe.